Let's look at another example of completing the square. Here we have y squared minus 8y plus 1 is equal to 0. We have a linear term, and we can't solve using the square root method when we have that linear term of minus 8y. So we will go through the steps here. We want to get the variable terms on one side and the number on the other. So we will move the constant to the other side by subtracting 1. We have y squared minus 8y is equal to negative 1. The next thing we want to make sure of is that we want to make sure that the a is 1. That's the number, the coefficient of the quadratic term. It is 1, so we can go ahead and say that we are done with that step, and we will move on to the next step here. This is where we actually complete the square. So what we want to do is we want to give ourselves a little bit of room here. Let's rewrite our equation. And we know that we're going to add something to both sides, the same thing to both sides of our equation that completes the square. So we will take half of our linear coefficient, half of negative 8, turns out to be negative 4, and we half it and then we square it, and then when we square it we get positive 16. We're always adding, because when we square it always becomes positive, so we're always adding the same thing to both sides of our equation. Now we get y squared minus 8y plus 16 is equal to a positive 15. What we want to do is, our whole purpose was to make this perfect square trinomial so that it factors as a binomial squared. So when we go to factor this, let's do the faster way. We know we're going to write it as a binomial squared. The left-hand side should factor as that binomial squared, and the constant will be on the other side. Let's do it the fast way. Remember that we are going to put the variable inside, and we are going to use the half that we took. So I'm going to put that minus 4 right inside the parentheses. That is just a quick, easy way of factoring that perfect square trinomial that we just formed. Now that we have factored the left-hand side, now we have that quadratic term and the constant term, and we are allowed to now use the square root method. So we can take the square root of both sides. When I take the square root of the left-hand side, we have a perfect square, or two of a kind underneath. So the square and square root cancel each other out. One thing we don't want to forget our plus and minus, and the square root of 15 actually cannot be simplified any further. So now we need to solve for the variable. Now, remember we said that when we want to get the y value, or the y variable by itself on one side, we need to add 4 to both sides. The question would be, do I need to separate? And when I add 4 to both sides, we can see that square root of 15 is not a like term to the positive 4, so we can actually just tuck that positive 4 right in front of that plus or minus, and we actually have our complete solution already solved for y. Let's look at one that requires that extra step 2. In this example, we have a 4x squared minus 3x plus 5 equals 0. We have that 4 in the front that we didn't have before. How are we going to solve this? Well, the first thing that we're going to do is we're still going to get all of the x terms on one side and the constant on the other. So let's go ahead and move that 5 to the other side. Now we see that the a, which means the coefficient of the x squared term, is not 1. We want to make this 1 by dividing everything through by a. So if I divide by 4, and remember if I do one thing to one side, I got to do the same thing to everything on both sides. If I divide by 4, 4 divided by 4 gives me x squared, and now I have that 1x squared that I want for my a, minus 3/4 x equals negative 5/4. So this is important. This is going to make this solving this equation much easier now that our x squared is just a 1x squared. But creating that fraction does make it more interesting for completing the square on the next step. We know that we want to write out our equation here. We're going to give ourselves a little bit of room. Once again, because we know that we're going to add something to both sides. We are still going to have the linear coefficient. It just happens to be a fraction this time. When I have that linear coefficient, remember we're going to multiply across. So the half that we get is negative 3 over 8. Negative 3 over 8. Now we half it, and then we square it. And we're going to put that in both sides of our equation. So what is negative 3 eighths times itself? And if you have to, you can come to the side and write that out. And top times the top, bottom times the bottom, we get 9 over 64. Positive 9 over 64. We see that on the right-hand side we have two fractions that need to be combined. What is the LCD of 4 and 64? The LCD would be 64. We need to multiply in a 16 at the top and the bottom of the first fraction. And we see that we're going to get negative 80 over 64 plus 9 over 64. And that gives us a constant of negative 71 over 64. We want to make sure that we reduce that fraction if we can, and that fraction is actually already reduced. Now we want to factor that trinomial that we created over here on the left-hand side. We want to factor that as a binomial squared. Now here's where it's really significant that we can factor very quickly and very easily by using the half that we took. When we took the linear term and we halved it or multiplied it by a half, we got negative 3 over 8. That is going to help us out a lot when we go to factor. We don't have to think about what the factorization is. It's always just the half that we took. After we half it, that's the number that goes in the parentheses with the variable. And then our constant that we got after we combined our two fractions, negative 71 over 64. Now we have our quadratic term equals our constant, and we can take the square root of both sides of our equation. The square root of the first is x minus 3 over 8. Square and square root cancel each other out. We don't want to forget our plus and minus. And we want to simplify this fraction underneath our square root. We know that we want to split it up as the square root of the top and as the square root of the bottom. Very convenient as that happens. Square root of 64 we know is 8. Square root of negative 71. What did we say was going to always pop out when I take the square root of a negative number? If negative is underneath the square root, we know that I will pop out. So let's go ahead and separate this as the positive 71 times that negative 1. And that's going to give us square root of 71 times I, all over 8. 71 can't be factored down further, has no two of a kinds underneath it, no perfect squares, so we can leave it as it is. So I'm going to go ahead and come down here and rewrite our equation now with the simplified form, plus or minus. I'm going to go ahead and write our fraction that we simplified. I'm going to go ahead and leave that I out to the side. Now we want to solve for the variable. One thing we notice is we said when we bring it over, we want to know if I add 3/8 to both sides of my equation, are these going to be like terms? And we notice that we have the I as part of this term, but there is no I in this term. So these are not like terms, so they will have to just sit side by side. So we do not have to separate our equation into two separate parts. We can just tuck that positive 3/8 right in front of the plus and minus. For this one we get two complex solutions. We'll put the real part in the first part and the imaginary part behind. This is my a plus bi form.